All right, let's get started. Well, before we get going, how many of you here are programmers? All right, I found the right place then. Excellent. How many of you deal with complexity every day? Yeah, that's what we do, isn't it? From the time we wake up to the time we go to bed. Well, I want to talk about what I do for a living. If you ask me what I do, I don't write as much code today as I remove code. And I go to companies, and I find that they have dragged themselves into enormous complexity. And I'm not the smartest guy in the world, but there's one thing that I do which is different from what a lot of people do. I often say there's a difference between an employee and a consultant, and I'm a consultant. An employee is like a parent. A consultant is like a grandparent. And the reason is, as a parent, you have to take care of the kid every single day. As a grandparent, you get to borrow the kid, and you return the kid at the end of the day, which is what I do. And I'm not attached closely to these projects. And as a result, I can critique it a lot better. I can tell them what I see. I can help them to remove complexity. Well, when I was a kid, I used to tell a lot of scary stories. Now that I've grown, I just talk about programming. And that is as scary to people. And when you look at projects in the industry, this whole talk is about my own journey, my own experience, things I've seen in the industry, things I've seen in companies. And I'm going to just document and talk about things I've seen. And of course, I'm just one person. But if I've seen these, I'm very convinced the world is full of complexities. And if we can work towards reducing those complexities, we can do a lot better. But of course, when it comes to developing software, they say that, and for life itself, that the only constant is change. And this is what Heraclitus said. And every day we are facing change, and things keep changing all the time. Now, when I go to companies, one of the things they're very eager to tell me is they tell me, oh, Venkat, we are agile. And I always tell them, I'm so glad we got that out of the way. Now let's talk about what you actually do. And this agile has become the mantra. Everybody keeps talking about it. But what does it really mean to be agile? Well, what it means to be agile is the ability to really adapt to change. That's what agile really means. It's the ability to really adapt to change. And if we're not willing to adapt, and if we're not capable to adapt, there's no point really calling it agile. Now, one of the tweets that I created that I'm actually kind of embarrassed because it was spontaneous. I was actually having lunch with my children, and in the back of my mind, there's always the thread that thinks about programming. And in the middle of the lunch, I pulled out my phone, and I started typing a tweet. And my two children who were next to me immediately looked over my phone, and they were like, Dad, no, don't tweet it. Well, that's what you do as a dad. You embarrass your children all the time. And when they said, don't tweet it, I tweeted it. But what really was surprising to me is that probably was the most retweeted tweets ever that I've tweeted. And I'm a little embarrassed that I tweeted this, but here it is. But this unfortunately reflects the truth. It'll be really funny if this was not true, in my opinion. But this is my tweet. It said, I've not set the wedding date yet. I've set the wedding date. I've not asked her out yet. This is how software projects are managed. Now, if you really think about it, unfortunately, this is the industry we live in, isn't it? So I always talk about a restaurant where this lady is sitting and having a meal. This guy walks over and says, sweetie, I've set the wedding date to be June 14th. We're going to get married in this particular hotel. Here's how many children we're going to have. Here are the names. Here's where they're going to go to school. And he goes on and on and on. And the lady looks at him and said, who the heck are you? And he says, I'm the project manager. Because that's how software projects are being made, isn't it? We set the delivery date. We set the scope. We set the team size. And then we tell this beautiful word, we're agile. What in the world does it really mean to be agile if we have set everything before it? So the whole point about being agile is being adaptive, to be able to change what we do, to evolve as we learn about our world around us. So in that regard, we definitely are trying to be agile, but we're not willing to be agile. But of course, the only constant is change, they say. But what really makes it hard to be agile? There are several things that make it really hard. But one of them, in my opinion, an observation is that complexity makes it really hard to adapt to change. Now, if you want to really adapt to change, you need to have the ability to change. But when your system is so complex, it becomes extremely hard to make any change to the software. Now, you may be sitting in this meeting, and they tell you, we need to make a change to this XYZ software, XYZ module. And as they are telling you, you realize the last time you touched the XYZ module, you could not go home for the weekend. You're going to convince them this is not the change we want to do. So when software becomes enormously complex, our ability to adapt to the change becomes really hard. But of course, let's not be naive about it. System design is complicated by nature. Now, we deal with complicated things around us. Nobody would dare to tell you that the tax, logic behind the taxation is really trivial, or the rules of the banking is trivial, or medicine is trivial, or so many other things like engineering is trivial. We are dealing constantly with things that are very complicated. And as human beings, that's what we do. We deal with complicated things. But when it comes to these things, unfortunately, though, that complexity, when we add complexity to what is already complicated, it becomes really hard. So what is really complicated becomes hard to work with when we add complexity to it. So when it comes to the software we build, there are two things we need to be very cognizant of. One is the inherent complexity, and the other is the accidental complexity. The inherent complexity is by nature based on the domain. The complexities of the tax law, the complexities of the banking industry, the complexities of how chemistry works or physics works, and the science, those are inherent to the nature of the problem and the domain we are working with. But unfortunately, though, we take the inherent complexity, and as humans, we end up adding what are called the accidental complexities. The accidental complexity comes from, unfortunately, the solution we choose. And when we choose a solution which has complexity, what do you normally do? You provide another solution to deal with that complexity. And that solution brings its own complexity. And this is called the vicious cycle. We get dragged in and beaten down, and eventually we suffer the consequences of it. So if we can, on a daily basis, try to understand the difference between inherent complexity and accidental complexity, and work really hard to tackle the inherent complexity and eliminate the accidental complexity, I think we will serve our jobs much better. So we are the victims of our own complexities. And these are not things that are dropped on our shoulder. Aliens didn't come and deliver this to us and walk away. This is what we do to create in our own teams. And when I go to companies, when I see them suffer with complexity, oftentimes it is them, they have created it, or usually they fondly tell me, oh, Venkat, the people who wrote this code don't work here anymore. Because it was somebody else who created it, but they don't work there anymore. They left off this complexity and walked away, and the rest of the team have to suffer with this. So I'm going to talk about a number of things that lead to complexity and how we can help reduce that. So the question to start with is, what makes software systems really complex? Well, I'm going to identify several things here that make software system really complex. The first one I'm going to say is too many moving parts. And we see this quite often in the software we create. There are way too many moving parts in it. And when there are many moving parts, what happens? Things just begin to fall apart. And it becomes really hard to keep up with these as time goes on. And the moving parts make system more complicated. This only becomes worse as we see today, because now we are living with the worlds of microservices. What does microservices mean? There are more moving parts we have to deal with. And this is going to make things even more complex, and we have to really make sure that the complexity is worth it. Otherwise, it's an accidental complexity we have to deal with constantly. Now, this reminds me of one experience I had with a client I was working with. Now, this was a company that started with good intentions. They had very smart developers. And when they started out, they really wanted to be swift and agile and responsive to their clients. And in their desire to do this, they wanted to make the software very, very flexible and extensible. Well, remember, extensibility is that holy grail in software development, isn't it? Because every software developer will tell you, I want to make software extensible. Well, by the time they called me, they were having troubles because they used to be able to respond quickly to their customers. Their customers would call them and say, we want you to deliver the software, and here are the things we expect. And they were in a very complicated business, and they would deliver very quickly. But over the years, they have gotten slower and slower and slower. And they called me and said, come take a look at it. What's going on? How can you help us? And when I went there, after signing NDA, of course, I started digging through their code. I'm not kidding with you. Their code in a lot of places had, well, there's a bird visiting us. How cool that is. So, in their software, there were several places where they had literally code that said, if the product is running for customer XYZ, then do this. Otherwise, and customers are embedded in the code so they can provide extensibility for every customer. But these developers didn't stop there. They wanted to make sure everything, I mean, when I say everything can be configured. Now, how did they make everything configurable? Well, they decided to take every single piece that could conceivable for a human being to be configured and turn that into an XML configuration field. So what it amounted to was, when they found a new customer, they would have to spend, I'm not kidding with you, they would have to spend 3 to 4 months customizing the product so they can deploy it. And you can imagine what a nightmare it is they've gotten themselves into. And Leslie Lamport once said, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Well, this is about the moving parts we are living with, but that comes in several flavors. When you have excessive configuration files, you have unnecessary components in your system. There are so many components you cannot even recognize where the code actually executes and what it does, and there are too many layers in the system. And I mentioned about how they went on to configure, and when I asked them, how do you really deploy a product? And they said, we will spend months finding out all the things we have to configure in XML, and we will start configuring it. And then I realized that for their product and for a lot of other products, configuration XML is configuration from hell. And no human should ever be asked to ever touch an XML document. This is an insult to the humanity, isn't it? Because this was not intended for human beings, unfortunately. And then I realized why I don't like XML so much. And I have this theory that I've developed over the years. And here's my theory. XML is like humans. They are very cute when they are small, but they are very annoying as they get bigger. And this becomes really hard to maintain the XML document as time goes on. And so this particular company came to the point where their ability to deliver software had a diminishing return as time went on. And they had to completely refactor their application to get away from this kind of configuration hell because they could not sustain the development moving forward. So the application becomes really brittle. It becomes error-prone, hard to deploy, really hard to test, and hard to reason. In fact, this is one of the things I tell my developers. If you are finding it really hard to test your software during development, it's an early warning sign it's going to become a nightmare in production. So this is one of the things I look for. Testability gives a lot of signs about how it's going to be easy or not so easy to maintain the product in the long run. So I talked about too many moving parts. The second thing I want to talk about from another experience is what I want to call as invisible changes. Now, this one, I'm very angry still. A team called me and said, hey, Venkat, we know that you know Scala really well. Can you do us a favor? We have a code written in C++. If you can help us to rewrite this code in Scala, and to get performance out of it, this would be really nice. Can you help us? I shouldn't have said yes. And I said, yes, I would be delighted to. Now, just to set the record here, C++ is not a new language for me. I have spent about 15 years of my life programming in C++. And I know the language fairly well. I've been teaching it for nearly 20 years. And I know C++, the state of C++ today, the changes that have been made in recent versions of C++. So I've kept up with the language. So it's not a new language. And to be fair, the code they sent me was not a lot of code. It was, maybe about 300 to 400 lines of code. Now I started reading the code. I wanted to understand what the code did before I rewrote it in Scala. And I was trying to understand the code. And I was reading it and reading it and reading it. And then for the life of me, I could not understand the code. And I felt absolutely like an idiot. And that's when I realized something that really distilled it to these words, in my opinion. There are two kinds of code that frustrate me the most. And I'm sure you would agree with this too from your own experience. The first is one that won't work. And it's like, damn it, why doesn't this code work? But even worse, the one that works but shouldn't. And this is extremely annoying. And I'm looking at this code and I'm like, why does this code work? And I'm not understanding why this code works. And in all fairness, all I saw was a constructor. And I'm walking through the constructor. This innocent object becomes a monster in like one step. And I'm like, okay. And I'm stepping into the constructor like an idiot. And I come to these methods. And I saw this one method called get something. What does get something mean? Get something means, well, go get some data. And I jump over that method, and this object becomes a monster. And I'm like, why would a get method suddenly populate this object with a huge amount of data? And I'm stepping in and stepping in and stepping in. And that's when I found out this was not a getter at all. It was actually doing a monstrous amount of work and populating, maybe I should say polluting, an object with the data. And it became almost impossible for me to understand what the code was doing. And that's when I realized the problem with this code is it doesn't walk the reader through what it's doing. These are really invisible state changes. And when you make invisible state changes, what you're telling the programmer who's reading the code is, you don't care, right? This is an insult to the other programmer. So when somebody is reading the code, you want to make it absolutely obvious. Because when you are walking through the code, your mind is reading through the current state, and there's a sphere of anticipation as a reader of the code. And if the programmer does something completely different and unexpected, it becomes expensive for us to maintain the code. So what does it mean the code is complex? Well, the code is complex because it doesn't follow our logical flow of thinking. And so it's important for us to avoid these sneaky changes we make in the background and make invisible changes. We want to make it absolutely evident so the reader is quite easy to see what's going on. Now, one of the reasons to do this is it becomes a time sink when we write code that does all these invisible changes. It becomes incredibly difficult for people to understand what changes the code is going through. Now, in this particular example, what I did is after suffering through this code for such a long time, I finally emailed them honestly and said, is there a research paper that describes this algorithm that this code is written on? And they said, oh, of course. We wrote this code based on this paper. I'm like, thank you. And literally, I threw the code away, read the paper, wrote the code in Scala, emailed it to them and said, here is the code, and please never come back to me. And this is why it really makes it angry, because it becomes incredibly hard to maintain the code. It becomes hard to understand the code. It's a waste of time, and that's not going to lead to any productivity. Well, the next thing I want to talk about is uncontrolled mutability. Now, we all have written code that mutates data. And in fact, languages like Java teach us to create fields and then to modify the fields. So it becomes almost natural and second nature for us to mutate data. Now, if somebody comes to you and says, is mutating data a bad thing? You're going to say, nah, it's okay to mutate data. And if they ask you, what about sharing? Well, sharing is a good thing, isn't it? Remember what mom told us? We should share. So mutability is okay. Sharing is noble. But shared mutability is devil's work. And the minute we bring in shared mutability, all things really fall apart. It becomes incredibly hard to maintain the code. There are race conditions. There is logical error. It becomes almost impossible for us to be able to work with the code when we have mutability in it. And in fact, I would argue this is predictably irrational if you think about it. Now, think about this for a minute. When they created multi-threading, if today you go around telling people you will create a shared immutable variable and you will access this variable from anywhere you want, what will happen? People will step away from you. They would say, gosh, what are you thinking? This is going to make the code really horrible, hard to maintain. We shouldn't do shared mutable variables. That's what they will tell us. But think about this for a minute. This is called predictively irrational. And we do this quite a bit in our lives quite often. We do things that are completely irrational. We just do it because that's the way we did things. Now think about the thread class for a minute. This was created as part of Java 1.0, isn't it? Now what does a thread class constructor take as a parameter? It takes a runnable as a parameter. Yeah, makes sense. So what's the purpose of the runnable? You give a piece of code, and that code will run in a different thread. Awesome. Now think about the runnable interface. What does the runnable interface have? It has exactly one method, isn't it? What is that method? It's called run. Now stare at that method for a minute. What does that method say? It says, I will not take anything from you, and I will not give anything back to you. How rude, if you really think about it. Now, if you're not going to take anything from me, and if you won't return anything from me, what does that even mean? This is like some employees at work you know. They never talk to anybody. You cannot ask them questions, and they will not give you answers, right? Now, that wouldn't be very useful, is it? Yeah, don't look around for that person. That's rude. Okay, so this is not a good idea. But what does this say? This says if you want to do multi-threading, you have to put a variable, assign a value to it, and let the other thread come and get it. Oh, excuse me, what does that mean? We will use shared mutability. Now, wait a minute. Isn't that what we are trying to really avoid when it comes to multi-threading? So these things can be really hard to imagine because that seems like it's predictably irrational when it comes to we want to really avoid doing something, and yet it is forcing us in the direction of what we should be avoiding. So we have learned the lessons of mutability over time. Mutability needs company. It often hangs around with bugs. And the more mutability we use in the code, the harder it is to maintain the code as well. So we want to really, as much as possible, reduce mutability in our code. But why is this so important? I'm going to the extreme to say state transition causes brain damage. So we as developers are suffering through this every single day. Now, I'm sure you've seen your story about this, right? As developers, we don't talk too much. We think a lot, and we deeply concentrate on our code. There's a reason why we do this quite often. And I'm sure you'll relate to this quite a bit. You know, you are sitting at your desk, staring at an algorithm. You're writing code. Maybe there's some music playing on the radio, but you've tuned out about this. And you're deeply thinking about this code, but what are you really doing? Here's what you're doing, isn't it? In your mind, as you're sitting and coding on the keyboard, around you, you have built this model in your mind. There's this object, and you know in your mind, this object has a reference to this object, and that object has a reference to this object. And you're right in the middle of taking this reference and changing it to this other object. And right at that instance, somebody opens the door and says, have you had lunch? and you just stare at them. And they look at you and say, I'm sorry, have you had lunch? And you say, what? And they say, you're weird. And they walk away. And you feel really angry. Why? Because when they interrupted you and said, have you had lunch? This model you built in the mind is on the floor. And you look at this and say, damn. And you got to put this back now. And you got to build all this hierarchy. And that is 25 minutes later. And then in the meantime, somebody says, would you like some coffee? And you're like, go away, right? You know, when people, and the beauty is, you may be pair programming with somebody. But when you're pairing with them, you're talking to them. But the rest of the world, what they don't know is both of you have the shared model in your memory. And it's wobbly. It's just hanging in there. And a third person comes to you and says, would you like coffee? Both of you get angry now. And this is something only truly programmers understand. Not only programmers understand, eventually people who have to live with programmers understand. This is something I will tell you, this is the best money that I ever paid. Now, I've been married for quite a while, and my wife, I took her to probably the best movie I've taken her to. This was the Social Network movie. And I'm going to play a scene from this movie. But right at that scene, my wife literally screamed and she yelled out, oh my gosh, I get it. I'm like, whoa, what just happened? And she's like, I really understand this now. I get it. So I'll play this and I'll talk about this more right after this. So let's give it a try right here. So here is the scene. Oh, he's wired in. That's what he said. So that scene, when he said he's wired in, that's when my wife screamed and said, now I get it. Now I know why you're so weird. You're not weird, you're wired in. And this was amazing, because the week after this, I was sitting in the kitchen, working away. One of my kids came over and said, Dad, I have a question. And my wife said, don't talk to Dad right now, he's wired in. I'm like, yes, this is amazing. Now, this is one thing to really think about. You know, when I got married, you know, a few decades ago, I'm very happy for that. But when my wife got married to me, she thought she was marrying me. It took her a while to figure out she didn't marry me, she married a programmer. And this was a shock for her. But she's extremely smart, she's very tolerant. She also understands programming to the extent to understand why I'm like this. But there was one day, soon after we got married, she has learned her lessons about me quite a bit, quite early on. But one day she said, I'm going to go shopping. And I told her, well, sweetie, if you want to wait for about 5 minutes, I'll get this work done and I'll come with you for shopping. And she said, great. And then she took the keys and went away. And I was kind of a little angry, a little bitter. And she came back and I said, I'm really sorry, but I told you I'll be done in 5 minutes and you didn't wait for me, you just left. And she put her hands on my shoulder and said, sweetie, I'm going to tell you this once. You better listen, and you better remember this. When you say 5 minutes, it's 7 hours in human time. And that's when it dawned on me. Because every time the boss comes to you and says, how's it going? What do you say? Almost done. And they shake their head and say, what does that even mean? Programmers have a different perception of time. When we say 5 minutes, the world has moved on for a few days, a few weeks sometimes, even months. And we are like, yes, that was not bad. In the meantime, they're like, gosh, that was like 2 weeks ago. And so we have a different perception of time. But that's okay, in my opinion. Because in my observation, this is a belief I have. Happiness is when the world truly understands programmers. Because we can sit down and code away. We can sit down and think about all these problems. We can think about all these concepts. And then we implement it. And all I require is leave the programmer alone. Make sure there's enough food on the table. They will go grab it. Never bother them. So when people say that programmers are antisocial, I've come to a very clear conclusion. Programmers are not antisocial at all. We're just social among the right kind of people. That's all it is. And we tend to really have all these complexities we have to deal with on a given day. Well, one of the things also that makes program really complex is lack of cohesion. So what is cohesion? Cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well. And a lot of times when a code is not cohesive, it becomes unnecessarily complex. Now, when a code does several things, it's got to talk to the database, it's got to do the tax calculations, it's got to update the UI, it's got to make sure all the logs are kept in check. Whatever it is doing, the more a piece of code does, the more difficult it is to maintain it. So why is it important to keep the code narrow and focused? Well, it's really to reduce the frequency of change. If a code has to change very drastically, it becomes really hard to maintain this code, and as a result, we want to reduce the frequency of change to the code as much as we can. Now, I remember going through a conference in Canada. Well, this was a very unique conference because this conference is organized exclusively by students who are in the university. And they completely take ownership of this conference. There are nobody else who's managing it, completely run by the students. And they invite industry experts who come and talk, give keynotes. And I was fascinated. I'm like, wow, this is entirely run by the students. And when I went there in that particular year, they had an event where the students were supposed to design different things using Legos. And as I walked around the corridor, I see all these designs the students have made. And I was really fascinated because there was almost an infinite number of things you could do with all these Legos. It made me realize how really cohesive each of these components are, but almost an infinite set of combination of things we can do to create around them. But of course, another area where I see a lot of problems is in dependencies. Dependencies, unfortunately, are something we cannot live with and we cannot live without. And we have to be dragged into these dependencies all the time. Now, talk about dependencies for a minute. We have to deal with libraries, and we have to deal with APIs, we have to deal with frameworks. And the minute we start a project, so many dependencies roll in. And that's part of the problem is to really work with the tool, we got to keep all these dependencies updated and in sync, and that becomes really expensive. The learning curve is really big as well, because if we have a lot of dependencies, when every single one of those dependencies changes, we have to invest the time to learn every one of them and keep up with them as well. That becomes really hard. Now, here's my analysis. I've been programming for about 35 years, and I'm going to say from my experience, I've had one hell of a programming career. From DLL hell to jar hell, through assembly hell to NPM hell, what is next? Well, in the Java community, I know exactly what that is called. We call it module hell. And that's what we are living through right now. But I remember as a young programmer, I would be dealing with DLL hell. And I would create these DLLs, and I would put it out on the network device. And suddenly somebody would say, your code doesn't work. I'm like, have you used the right DLL? Uh-huh. Are you sure about it? Of course. And then 30 minutes to an hour later, we'll find out they're using a wrong path. And this was relentless. It was really hard. But I'm so glad we don't have to deal with DLLs now. But now, of course, if you're in the Java community, JavaScript community, you're going to use NPM. NPM is directly from hell. Because if you do NPM, it will download the entire internet with vengeance. Well, the other day I was on the flight, and the captain said, folks, the ride is very smooth. I'm turning off the seat belt. If you want to move around the cabin, please do. And I shouldn't have done this. But I opened my laptop, and the only thing I did was NPM install. And immediately there was turbulence. And the seatbelt light went on, and the captain said, folks, we're having unexpected turbulence. Please sit down. I said, sorry. And I closed my laptop, and I promised never to do this again. Well, the point is, it becomes really hard to maintain these. Well, I was talking to a developer recently, and he said, oh, I don't have any of these problems, he said. I was very curious. I said, really? How come you don't have any problems? What do you do? What do you do? What kind of language you're using? He said, I program in Java, he said. I said, wow, how do you deal with your dependencies in Java? He said, oh, that's very easy for me, he said. I use Maven. I had to tell him the bad news. You don't use Maven. Maven uses you. And this is something you need to be careful about. Well, the problem is all the dependencies will drag you and beat you down. And by the time you configure all these dependencies, it becomes incredibly hard to maintain the software. And the complexity, that's another complexity we have to deal with. Well, dependencies are really hard to maintain. And they become obsolete very quickly. And they also become incompatible. Well, I was working with a team of JavaScript programmers. And I asked the developer, about this particular project. I know what the application is. And when you look at an application, you can kind of measure how complex the application should be. And he said, oh, we don't run automated tests anymore. I said, oh, really? Why did you quit running automated tests? He said, because we upgraded some of the dependencies we have, and those dependencies don't work very well with our test. We didn't have time to fix it, so we got rid of those tests, he said. Well, that's one way to fix the problems. And I looked at him and said, really? How many dependencies do you have? And he said, oh, on this product, we have about 150 dependencies. I said, oh my gosh, are you serious? He immediately showed me the dependency file and said, yep, look at that, that's what we have. And I looked at him and said, for your application, I wouldn't think you need this many. Can you tell me why you have 150 dependencies? And without missing a beat, he said, because we found them. And I'm like, okay, thanks for the honesty, because this is the world we live in, isn't it? You are going to lunch with your team, and while you're having lunch, you overhear somebody in the next table talk about this XYZ package in JavaScript, and immediately look at your team and say, hey, are we using XYZ? And they're all very sad. They're like, no. And 30 minutes after lunch, it's in production, right? Why? Because how could we not use XYZ package, right? It's beneath us not to have all the packages. And then, of course, I love meeting programmers in conferences. Try this someday. Maybe not to this group because they know because I told you this. But go around to your user groups or go to your conferences and you sit down next to somebody and say, you just make a small conversation. You tell them, hey, how's it going? Yeah, great. So what are you working on? And they will clear the throat and say, I'm working on a very large software. Nobody ever tells you, I work for a small software, right? I work for a large software. And you're like, wow, what does it do? And they say, it causes ulcer. We cannot go home. I've not seen my kid for 7 days now. No, I'm not asking what it does for you. What does it does for the users? Oh, we don't know that yet, right? And why are we building complexity like this? And then you ask them, tell me more. And they say, it's got 7 million lines of code. And they're proud because they are proud to tell you, I go to work every day and I deal with this monster. But I want to meet that developer who says, you know what? I work in a company where we build a small software. It works. We make money. Our customers get value. I go home one time. I play with my kids. It's boring. That would be great, isn't it? But no, we want to create monsters. We want to walk around limping and then with scars on our body, and they look at there and say, there goes our best programmer, right? Why are we so keen in creating complexity and taking pride in dealing with? This is called self-inflicted wound. We do this to ourselves as programmers. And if we can wake up and say, no, we don't need to do this, we'll be far off. Well, part of the reason for that is leading into the next one. I want to call this technology infatuation. This is dangerous because when we are working, we have this constant desire to say, what else can I use? What else can I use? We are eager to add more than thinking about removing things and reducing complexity. And technology infatuation can be really troubling for us. Now, technology infatuation is where we are keen on using a technology even if it is not relevant or useful. And I remember one particular day, I was working with a developer in a company I was consulting. And they said they're going to use one particular technology. And I looked at the developer and said, excuse me, I know what your product is. And I cannot imagine why you would need this technology. It is not a right fit in my opinion. Why are you choosing to use this? And he lowered his voice into whisper, and he came near me and said, hey, Venkat, I've got a request for you, he said. I said, what is it? He said, please don't talk about this again. And don't tell this to my boss, because we convinced my boss we cannot develop the application without this particular framework. And I'm like, oh, I get it. There's a name for this. It's called resume-driven development. And resume-driven development is we use technology because we can put that on our resumes. We'll talk about that in a few minutes. But one of the things I want to ask when deciding a technology is reversibility. So what is reversibility? Reversibility is our ability to back out of decisions. And if I make a decision to use something today, and 6 months from now, I realize that is not the right choice, how easily can I reverse it? How easily can I back out? So when I sit with my developers to do design and architecture, one of the things I constantly ask them to think about is, how reversible is this? If it is really easy to reverse, I'll make the decision a little lighter. If it is really hard to reverse, I want to spend more time before we commit to this. Because what is not reversible is expensive and becomes really hard for us in the long run. So reversibility is a very important question we should be asking constantly, almost every day, especially during design and architecture. So it's the ability to back out of design and architectural decisions, and we want things to be reversible, and if they are not, we want to take more time to really commit to them. Well, let's think about library versus framework. Now, I would want to reduce my dependencies. But when it comes to dependencies, I might be a little bit open to use libraries. It's the frameworks that scare the heck out of me. Well, there's a reason for it. A library is what you use. A framework grows around you. You call into a library. A framework often calls into you. And if you think about lock-in, when you use a framework, you often get locked in. If somebody comes to you and says, change the library that you're using, you may kind of say, but you may put your effort to it and you may do it. But if somebody comes to you and says, change the framework you're using, you're going to say, get out of here. This is not going to be really possible because that's expensive. Similarly, a programming language is really hard to reverse. If I walk into a team and say, from tomorrow, don't write code in this language, change all your code to a different language, they will throw me out of the building through the window. Doesn't matter what floor I'm on, because that's expensive. That is not to say you cannot mix languages, but you cannot just throw away your code and change languages so easily. So here is a way to think about it. To use a library, the use of a library is easier to reverse, relatively speaking, than using a framework. And here's a really stupid comparison I want to make. Using a library is like dating. Using a framework is like entering into a marriage. You don't want to take it too lightly. You can have a few bad dates, but don't want to have too many bad marriages. It becomes very expensive and damaging. So you can use the library easily, and you can even try multiple libraries over a weekend. Maybe that's called speed dating. But the point is, you want to really take more time to commit to a framework. Now, just because a library is reversible doesn't mean it's always reversible. One of the things to think about is this idea of what is called the surface area. So if this were a library that I want to use, and if this library is being used in my code, I can say that is my surface area. If you decide not to use this library and change to a different library, the only piece of code I have to change is that piece of code. On the other hand, if the library is like this, where I'm using it really extensively in a lot of touch points, if the surface area is really big, that becomes more expensive to replace this library because I got to change all that code now if I have to really make a change. So you want to reduce your surface area for ability to reverse out of libraries much more easily as well. Well, talking about libraries, I'll talk about when I was really young. Now, my children always feel very fascinated when I say this, because when I was young, there was no internet. like the way we have internet today. And they look at me and say, really? How do you really get information then? I mean, this is fascinating, isn't it? Recently, I was visiting a friend of mine, and he has a 4-year-old daughter. And it's just amazing, the world we live in today. And her mom was, listening to her, but this 4-year-old daughter was pretty assertive. She was telling me about stuff that I should know. And as she was telling me about things, her mom said, sweetie, you seem so confident. How do you know about this? And without thinking, the daughter, the 4-year-old said, because I Googled for it. And I'm like, wow, this is amazing, isn't it? And my children always look at me and say, if you didn't have Google when you were a kid, then how did you find stuff? So that's always really, interesting to see how the world was before the time of the internet as we know it and before Google. But when I was young, we would want to use libraries. If I want to use a library, I would often hear about it, find it in a trade magazine. We'll read about it because there was no browsers to browse. There were no blogs to read. And we would read about it. And once we read about it, we'd have to go to the boss, and there was no open source. And we would go to the boss and say, I want to buy this product. And when they tell you you want to buy the product, that go through an approval process, a procurement process. By the time you hear from them, you'll forget why you needed this for. And if you still needed it, you will order it, place an order, and eventually, after several weeks, if not months, this will arrive in the mail. And you will get a tape drive. And I remember fondly those days when I would take these tape drives and I would walk to these machines and install the tape drives and spin them around and start them. And then you start installing your software from the tape drive. Well, when there's a tape drive between you and the software you need, you don't use too many software to build your system. I'm not suggesting that things were a lot better back then, but I can definitely tell you things were a lot slim back then. We reduced the dependencies a lot back then. For part of the reason was it was really hard to really bring in dependencies. But today, dependencies are a click away. And if somebody mentions to you, you can Google for it, and within 30 seconds, it's integrated into the product. And within minutes, our product contains all the dependencies you can think about. And so we bring in more. And when I see resumes, I look at the list of products listed in there. And I often ask the candidate, do you want to work with all of these things? If a person lists 70 things on the resume, I get scared. Because what they're telling me is, when they come and join my product, they will bring 150 things and never deliver the product. I don't want people to bring in complexity. I want them to bring in delivery capability. And that's why we want to avoid this resume-driven development, because it's pretty dangerous. I don't want people to use software so they can put that on the resume. I want them to use software because it solves real problem for them. So we have to be very careful in evaluating it. But I'll share with you a very hard story related to this, and this still breaks my heart. This was back in 2004 timeframe. I was working for a company. And I was a consultant working for this team. And as I was working for this team, we were developing software which was supposed to be released in 6 months. And we were working really hard with it. But we needed help. And this was a time when the US economy was in recession. People didn't have jobs. But it turns out when people don't have jobs, it's also the same time it's hard to find people as well, the good people, that is. And we were interviewing almost every day. And one day we were interviewing a person, and in all honesty, my jaw was on the floor. I'm like, wow, this guy is amazing. And after the interview was over, this person did a demo during the interview. After the interview was over, the person I was reporting to, he came around and he said, hey, Venkat, what do you think of this guy that came for an interview? I said, don't waste your time talking to me. Go hire him now. This guy is brilliant. I am selfish. I want to learn from him. He knows so many things. I'm eager to work with him. Go hire him now. And he said, yeah, I hear you. What do you think of the framework he demoed? I said, that's the best framework I've ever seen. It's really cool. Don't waste my time right now. Waste your time right now. Go hire him. You need to be talking to him. Yeah. But I have a question for you. What do you think of us using the framework? I said, whoa. Sit down now. Let's talk about this. we need to release this product in 6 months. Do me a favor, hire the guy, don't talk about the framework. Don't even consider it. And if you really, really want to use the framework, tell you what, let's release the version in 6 months, and then we will do anything you want. We'll use any framework you want to think about. We'll talk about it then. He said, but wait a minute. Did you hear him talk about distributed, persistent messaging? I said, listen, you never used those words in one sentence to me ever until now. This is called infatuation. Don't do this. Yeah. But did you notice the fault-tolerant, distributed, transaction, and persistent database he has? Never use those words in a sentence to me again. You are infatuated. Please don't do this. Hire the guy. Don't talk about the framework. 2 weeks went by. I was sitting and coding. I remember, I could never forget. It was February 2004. And I was sitting and working on my desk. He came and sat on my desk and said, hey, Venkat, I got a great news for you. I said, yeah, what is it? Well, we offered the job to this guy, and we're happy to tell you he accepted it. I said, oh my gosh, this is great. We're going to have fun. I'm absolutely happy. We're going to learn. We're going to rock. This is great. And I gave a high five. It's like, awesome. I couldn't be happier. Oh, by the way, as part of our agreement to hire him, we have signed a contract to use this framework. I said, tell me you are joking. Tell me you are saying this to make me angry. He said, no, this is true. I said, okay, if that's your decision, what you need is somebody who will run with you and not spend every day telling you you are wrong. So I just resigned. He said, I know you're going to do this. I already told my boss before I came here, the minute you know this, you're going to quit. I said, at least I'm predictable. I'm glad to hear that. Could you do me a favor? If you have any other project, call me. I'll come and work with you guys on that other project. But this project, you're doing it wrong. I said it once. I'm not going to be back here again. I'm leaving. And I just packed my stuff. And I said, how long would you take to finish this? Oh, we're going to be finished in 6 months still. I said, good luck with it. All my best wishes. I'm going home. And that's one of the very rare days I actually went home when the sun was still out. My wife looked at me and said, my gosh, you're home already. I said, yes, I quit. And she said, what does it mean you quit? I said, that means I don't have a job. And she said, well, in that case, I got some dishes for you in the kitchen. That's how she is. And so I was very happy doing dishes for a week until I found something else and moved on. And this was February 2004. And my phone rings in August 2005, 18 months later. I picked up the phone and said, hello? Hey, Venkat. Hey, how's it going? Go ahead and say it. I'm sorry, I don't understand what that means. What do you mean, go ahead and say it? Go ahead and say it. I told you so. I said, oh my gosh, what happened? Well, we have spent 18 months. We're not done with finishing the project yet. We've taken way too long. Everybody is angry. The boss is very upset. So what do you want me to do? Well, I was wondering if you'll come and help us. I said, listen, I'm sorry. There's a reason I ran away. I ran away because when I was younger, I would have done that. But I'm old enough to work on projects that will succeed. And I knew this sign written on the wall. And that's why I quit. When the economy was poor, I quit and ran away. I didn't want the job. Sorry, I won't help you. My phone rings again, February 2006, 2 years later. I said, hey, what can I do for you? Oh, I know, you don't want to come and work with us. That's fine. Just come over here, look at what we have done, write a report, get paid for the day, and you're done. I said, gosh, you guys are done. Absolutely, come take a look at it. I'll be happy. So I go over there, 8:30 in the morning. I walked into the room, and there's a computer sitting with the software running on it, with a little instruction on what to use sample data. And I sat there, I entered a search, and I clicked on a button. 25 seconds later, a little data popped up. I said, interesting. And I did this again. This time I timed it, 25 seconds. And I looked at him and said, that click, that one click took 25 seconds. He said, uh-huh. I said, I did a profile. That one click created 1,864 objects. He said, yeah, it's object-oriented. I said, okay. In production, the database, we don't talk about it. Here it's local, there it won't be. I said, in production, the machine speed, don't talk about it. This is twice, if not 4 times faster than what we will see in production. So you cannot change anything in the infrastructure to make it faster. Nope. And then I said, oh, excuse me, where is everybody? Because I'm looking around and the floor is empty. So where is everybody? He said, oh, the boss got so angry, he fired the entire team last week. I said, oh my goodness, so the product is here, but there are no developers to fix it now. He said, uh-huh. I said, what do you want me to do? He said, fix it. I said, I'm sorry, I'm a mortal human being, I'm not a magician. I can't do it. I'm not kidding with you. I was there till 10 p.m. He wouldn't let me, and I escaped at 10 p.m. And I told him I will never send an invoice because I don't do postmortems. This is dead. And it's really depressing to see a capable team just taking a product and driving it to the ground because all they want to do was be infatuated with technology. There is really no reason to do it. So don't build what you can download. Don't download what you really don't need. And this is something I keep stressing with my teams all over again. The less you have, the better it is. And look at the cost of not creating something, but look at the cost of maintaining it in the long run. Not just have a short-term vision of, hey, look how cool, how easy it is now. What's the cost of maintaining it in the long term? That's very important as well for us to consider. Well, one of the things to think about often is accidental complexity we have to deal with. Concurrency is one of them. When we start using thread, it becomes overly complex over time. So we look at a problem and said, we can solve this with a pool of threads. Now we have a pool of problems. Concurrency is another complexity we often bring in, especially when we don't need it. I remember in this one organization, they were dealing with enormous problem with complexity. And when I came in, I asked them the question, why do you need it? After several hours, we found out there's no reason to even have concurrency. And yet, 75% of their code was written to deal with concurrency that doesn't even exist in the application, which is kind of scary when you see situations like this. But one of the reasons for this problem is concurrency can be a wild beast. Here's an example to consider. If you look at this code, I have a done which is false, which is a Boolean variable up here. The done is false to begin with here. In the thread, I say running, then while not done, I keep incrementing the count. When the done is true, I will come out of the loop and print exiting thread. Then of course, down here I sleep for 2 seconds, and then in the end I print out setting done to true, and then set done to true. Well, that seems to be a really simple code, isn't it? Something we can quickly relate to and see how we can use it. But I'm going to just go ahead and compile it and run this code really quickly so we can see how it's going to run. So when I execute this code, you can see in main running, and it says setting done to true. But you can see the code never actually came into this line of code right here. And we could be waiting for a very long time. Now, when you look at this, why does this code really complete? Well, before we answer that question, let's do something absolutely stupid to make this really confusing. So I come into the loop right here, and I'm going to say try, and I'm going to say catch exception right here, and I'm just going to say simply thread dot sleep for 0. And this is kind of shame, isn't it? Sleep 0, that's all I did. So when I go back and run the code after putting a thread sleep 0, you'll notice when the 2 seconds is done, the program quits. Now, you can ask the question, why would a thread sleep 0 make any difference at all? Well, the reason for that, unfortunately, is a lot of people who get into doing multi-threading don't think about, me included, don't think about the Java memory model. Well, unfortunately, without learning about Java memory model, it's impossible to really deal with this properly. Now, the answer to this is, when they built the concurrency model in Java, The concurrency model in Java is like Harry Potter. Now, why is Harry Potter so interesting? Well, the reason is there were Horcruxes, and there were several of them. You don't know where they are, and you don't even know how they looked. I mean, imagine if Harry Potter was written in a way, in the beginning they said, there are 7, and here's how they look, and here's where they are hidden. We won't watch the movie. It's boring. Well, that's why Java concurrency is so exciting. They have these Horcruxes. And these Horcruxes are helpful to cross the memory barrier. But they won't tell you where they are and how they look. And we then spend our effort trying to figure this out. Now, if you're interested in this, I cannot recommend this book enough. This is the best book ever for Java programmers, in my opinion. It's a book written by Brian Getz. It's the scariest book ever written for Java programmers. It's called Java Concurrency in Practice. Before I read the book, I used to think that no human can get concurrency correct. After reading the book, I know no human can get concurrency correct because it is that complex. It's unbelievably complex. All the things you have to keep in your mind to make this work is just mind-boggling. Well, a key design skill we need to develop is the ability to discern accidental complexity from inherent complexity. And if we can make inherent complexity manageable, and we can remove accidental complexity, and I'm going to say concurrency solutions in Java in general are accidental complexity. Another place where accidental complexity comes from is imperative style of coding. Now, what happens in imperative style of coding? Let's take a look at one example to see where that could be a problem. I have a function called isPrime that tells you whether a number is prime or not. What I want to do is the following. Given a number n and a number k, I want to find out the total of the square root of the first k prime number starting with n. How do I do this? Let's try to write this code in the imperative style of programming. So what do I do first? I'm going to say double result is equal to 0. Int index is equal to n. Int count is equal to 0. I want to return the result when we are done with this in the end. That's what we're going to do. Then what am I going to do? While, and I'm going to say count is less than k. At this point, what do? You come to a grinding halt and you ask this vexing question. Is it less than or equal to? Do you ever ask this question? Every single time. The only purpose of this symbol is to make us feel really stupid. Because you type it and you stop and say, huh? And you're trying to compare it. And it's never easy to find out. Then what do? If you say isPrime of index is true, then I say result plus equal to, because we want a total, math.square root and of what? Of the index, because we want the first k prime numbers. Well, if I say that's the code I have, and I ask you if it is correct, what are you going to say? No, it's not right. Why not? Because I better add the index, increment the index. Great, I done. Is it correct? You say, no, you got to increment the count. Is it correct? No. You say it's got to be outside. Well, it turns out one has to be inside and the other has to be outside. So you have to keep the count increment there and the index increment here. Look at all the complexity you have to deal with. Now I'm going to ask you the question, is the code correct? What do you think? I'll tell you one lesson I've learned from programmers. Programmers are the smartest people on earth. Because when you show a piece of code and ask them, is it correct? They will never tell you it's correct. They always tell you it looks good. Because 3 weeks from now, it's not working. And you never want to be caught saying, but you said it's correct. Like I said it looks good, that's all I did. Well, this is a very complex piece of code. It produced a result. You can ask me, is the result correct? All I can tell you is it looks good. So, but imperative style of code is inherently complex, and it's packed with accidental complexity. Declarative style keeps our focus and makes it easier for us to maintain the code. So what we could have done is, rather than working so hard on the piece of code, we could try to do something a little different. We can say return a stream.iterate. And we can say, given the index n, given an element, give me the next element in here. And then finally, we can say filter. And what am I filtering? Sample in this case. And I can ask for is prime over here. And then once I get the prime number, what can I do? I can say map to double. And in this case, I can ask for math square root. But then I can say limit for this one just to the value k. And then finally, after this, of course, perform a sum operation on it and return the result for me. So that becomes a lot easier to write the code. The code begins to flow like the problem statement. So given a collection of numbers starting with n, give me all the prime numbers, give me the square root of those, but give me only k of them and total them. That becomes very expressive. The last thing I want to mention here is entwinement. Entwinement is where we take two different things that don't belong together and we mix them together. This is a very common problem a lot of developers do. And the people who created Java are no exceptions to it, unfortunately. For example, when Java was introduced, we have the finalize method, which is a really terrible idea. Why? Because finalize is called when the garbage collector is called. Unfortunately, in Java, garbage collector is automatic but non-deterministic. You don't know when it'll be called. Well, the garbage collection of memory is automatic. How do you clean up your resources? Well, they introduced finalize and said you can put the code to remove your resources in there. That was a terrible, terrible idea. Why? Because you don't know when it's going to be called. And because you don't know when it's going to be called, your resource will end up being starved. And as a result, a lot of errors come through the code. Finally, in Java 9, they took the measure to deprecate finalize. They figured out this was a terrible thing to do. And it took them so many years to deprecate finalize, but it was a bad idea from day one. And that's an example of entwinement. Entwinement is when you take two things that don't belong together and you put them together accidentally. We do this all the time as developers, but being aware of that can help us remove that complexity. Well, Rich Hickey has a name for it. He calls it complecting. Complecting is just entwinement. Complecting things is the source of complexity, he says. So when you take two independent things and bring them together, we end up creating unnecessary complexity. Being aware of that can help us to remove that burden. So we talked about a number of things here. We talked about too many moving parts leading to complexity, invisible changes that make it really hard for us, uncontrolled mutability that makes it really hard for us to manage the state and maintain sanity. Lack of cohesion makes it really hard for us to keep up with change because the frequency of change is really high. Excessive dependencies bother us with so many ways, including inability to keep up with the change in so many fronts. Infatuation with technology can be very dangerous in making things unnecessarily complex. Concurrency, low-level concurrency can lead to complexity. Imperative style of programming as against functional and declarative style, and entwinement. To wrap up what we talked about, we should learn to deal with complexity and have the wisdom to minimize it. We cannot completely remove complexity, but every day if we can pay attention and ask question, is this accidental complexity? And if it is, put the effort to remove it, I think we can serve a lot better. You know, a lot of times we as developers often like to complain. Often we like to say, you know, we have a good intention, but the management doesn't give us tools. The customers don't give us these flexibilities. But I want us to take a minute to think about and point at ourselves. What can we do as professionals every single day? This is not about managers. This is not about customers. This is not about everybody else. It's about us. If we can spend a minute removing unnecessary complexity, I think we can really lead our profession to a better way of delivering software, and that's something we all should strive to do every single day. Because a maintainable code is a gift we give ourselves for the future. And I think all of us will be very thankful for the gift we leave for ourselves. Hope that was useful. Thank you.